All right, so here we're going to take a look at the property, the product property of the logarithms. The log of AB equals the log of A plus the log of B. And I'm going to do a proof. This isn't a very too involved proof, and high school students, this is something they should be able to follow. So to do this, to prove this, the first thing we want to do is let's let x equal the log base A of capital A. And we will let y equal the other one, log base A of capital B. All right, so now what we got to do is, which we do a lot of times for logs, we got to go back to the definition. And we go back to the definition, and so let's just say by definition, x equals the log base A of A if and only if a small a to the x equals capital A. Similarly, y equals the log base A of capital B if and only if a to the y equals b. Okay, so now let's take the product. Let's look at capital A times capital B. Well, capital A times capital B has to equal a to the x times a to the y. Okay, so that's good. Well, here we know the properties of exponents. This we can write as a to the x plus y. We add the exponents. Now let's take the log base A of both sides. Again, with an equation, you do anything to both sides, and you're going to maintain an equality. So let's take the log base A of both sides. But from an earlier property, you know, the log base A of the log base small a of small a raised to the exponent is just equal to the exponent. So the log base A of AB is equal to, like I said, the exponent, which is x plus y. But x is the log base A of A, so this gives us the log base A of AB. It's equal to x plus y, but x is the log base A of A plus y, which is the log base A of B. And we prove that property. So that's not a too complicated proof. Another thing I like to do with students here is, and I think this is probably a little more important, at least at the level of high school, is to show that this is true. Let me just erase the proof. Let's show that this is true just by using some numbers. Or at least show that it's true for a specific case. Let's consider the log of 15. So you have students get out their calculator, type in the log of 15. Well, 15 is 3 times 5. So we could think of that as that. But according to this, that better equal the log of 3 plus the log of 5. So I have students get out their calculator, plug in log 15, then plug in log 3 plus log 5, and they'll see, sure enough, they're the same thing.